This is Geometry Semester 1. It's the third unit called Area and Perimeter. It's the fifth lesson, Area and Perimeter of Trapezoids and Parallelograms Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find the website. Hope you can find it that way. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So just to model that quickly, let's pull up the website and show you where the notes are. All right, can we see this? So let's see. Go back. Here's the site, creatormath.weebly.com. Type that into Google. Hopefully you can find it. Here's what the home page looks like. Remember that all of the composition book stuff is on this home page, right? Just go down to where you see the picture of the comp book or the words that say comp book and follow all the directions below that to fill in your comp book. We're going to go to geometry because we need notes. All of the notes, videos, vocabulary, etc. is under the geometry tab for geometry. It says vocabulary, geometry, practice, study PDF. You need this PDF for all of your vocabulary practices. Every word of the whole year is on there, and that'll help you get A's on those assignments. Scroll down to the correct semester. That's important to match up depending on which ones you're in. Make sure it says table of contents. This should have been written. This entire table of contents we're going to look at right now should have been written on pages 2 through 6 of your composition book a long time ago. If not, stop what you're doing right now and write this in. We're going to move down to where we see the current unit we're on. We're on area and perimeter, and it looks like we are on the fifth lesson. So 1, 2, 3, 4, 5. Here it is here. Area and perimeter of trapezoids and parallelograms. These are the pages that the notes go on in your comp book. Please don't use this video to find these pages, but go find the original table of contents. At the time you're viewing this, those page numbers will probably be different than what you see here, so this will mess you up. Don't use this. Use the actual table of contents. Here are the notes. Let's click this. Sometimes I have to open it a couple times to get it to load. Not in this case. It loaded on the first time. You'll be able to expand it out and then copy these notes into your comp book on the correct pages as we've already referenced, right? So this is going to talk about area of a trapezoid. There's a base 1, a base 2, a side 1, a side 2. Base 1, base 2 added and divided by 2 is an average of the base lengths times the perpendicular height, or height. We're looking for units squared on area. For perimeter, we're just adding up base 1, base 2, side 1, side 2. We just add up all the units as we go around to find perimeter. Triangle. We've got area and perimeter of a triangle with particular attention to perpendicular height. We'll talk about as we do the problems. Parallelograms in here, base times height. Perimeter is each side length just going around. And again, we're looking for perpendicular height. There's a great graphic of an airplane I drew on the board. So altitude is another name for perpendicular height. That is the distance the airplane is from the ground. Notice that we are measuring that distance at a perpendicular height, so it's 90 degrees to the base of the airplane, 90 degrees to the ground. Any kind of slanted distance, like see how this is a slanted distance? This is not the height. This is the length of that side. The height would be here, and notice the difference. This one is perpendicular to the base, this one is not. That's probably the biggest error we see when students are working with area of these different shapes, triangles, trapezoids, and parallelograms. So height of a trapezoid is the parallelogram is the altitude, and it's the height an airplane is over a particular point in the ground. There's some problems here you can put into your comp book. Go ahead and solve those if you can. And with that in your comp book, we're going to go straight to the problems here and see if we can work through them. Can I get this to focus any? It's just not printed very well. I'm sorry, you guys. Why are the units for perimeter raised to the power 1? So, we have this idea of 1D, one-dimensional, 2D, two-dimensional, and 3D, right? A perimeter is a one-dimension. That's a length, like this. This one says, why are the units of area raised to the power 2? Because it's two-dimensional. So here's a shape we might calculate an area for. Notice 2 dimensions, horizontal and vertical. So here we had horizontal. Here we have horizontal and vertical. Now let's go to 3D, and I might have left a little bit more room here. 3D is going to be raised to the units 3 because it is in 3 dimensions. Horizontal, vertical, and depth. Those 3 dimensions. 1 dimension, 2 dimension, 3 dimension. Unit to the 1 power, unit to the 2 power, and unit to the 3 power. If you can get this down, that this is 1-dimensional, 2-dimensional, and 3-dimensional, a lot of this length, area, and volume will clear up in your mind. And I didn't really get this, I think, until college, probably. In high school, I didn't get it. But eventually, I was like, oh, this all kind of flows together and makes sense once you understand the big picture. So what are the common 3 dimensions used? Let's glance at this. You can have length, width, and height. That's this right here. So length, width, height. You can have horizontal, vertical, depth. Notice I'm going over the same 3 dimensions but with different names. And you could also have x-axis, y-axis, and z-axis. Those are another set of names that might be added in there by the time I get to this. I don't know if I will or not. But again, x-axis, y-axis, z-axis. All right, so all of those are different names for the same 3 dimensions, and that's all you're using are those 3 dimensions in math. We do not go into the 4th dimension. I would say that's more the realm of physics, because I think the 4th dimension is time. And then, you know, scientists speculate that there are 20 dimensions out there. There are many dimensions that we can't see as humans. So, again, math comes into play in your philosophy degree. Given the following graphic, what's the area? So this is a parallelogram. I'm pretty sure of it by the way it looks, but let's just check the numbers. This distance here is 9. Why? Because the x value is 0, now the x value is 9. This distance here is 2 going to 11. Well, 11 minus 2 is 9, so this is 9. What is the perpendicular height here? The perpendicular height is we had to go up from 0 on the y up to 5. So this is 5 high, is this perpendicular height here. So I think because this one is shifted over 2 and this one is shifted over 2, I definitely know this is a parallelogram. Okay, so we want area. Area equals base times height, and it's going to be perpendicular height. So base is 9, and let's call them units. I don't know what the units are. Did they tell us? Nope, I don't know. But let's call them units. Times the perpendicular height, which is 5 units. 9 times 5 goes first, because they're numbers. You get 45. Units times units is units squared, you guys. That's where the square units come from in area. So we should have 45 units squared. All right, I guess I've been circling them. 45 units to the power 2 units squared. All right, given the following graphic, what is the area? So this is a trapezoid. Area for trapezoid, go back to the notes, 1/2 base 1 plus base 2 times perp height. Area equals 1/2. So this is base 1, 0 to 9. This is base 2. How far is it? We're going from a 2 to a 7. 7 minus 2, this has got to be 5 long, right? We don't have a grid or anything, so we got to use, and remember, this is the XY coordinate plane, right? The Cartesian coordinate plane with an x-axis and a y-axis and an x value for each of these coordinate point locations. So here are the 2 bases, 9 and 5. So we're going to do 9 plus 5 here. That gets a parentheses. Then we're going to divide it by 2. Perpendicular height is we went from 0 on the y up to 5. So this is 5 high. All right, so we're going to go 5 here. Just to get units in, this is units here, because we don't know what they are right here, I don't think. Nope. And these 2 are going to have units on it. So units are in here twice. These have a units, and this has a units. So 9 and 5 is 14 divided by 2 is 7 times 5, and units times units is units squared. So area equals 35 units squared. And here they help us out a lot. We could have looked at the answer base 1 plus base 2 divided by 2. That's the average of the bases. That's what we did here. And times perpendicular height. That's what we did here. Here's the calculation, 35 units to the power 2. All right, AB equals CD equals 5. AB equals CD equals 5. These are 5 long. That makes this an isosceles trapezoid. Isosceles, which I can never spell, which means 2 equal sides. 2 equal length sides. Okay, sides. Man, I can't write either. So These tick marks tell us that too, you guys. Tick mark here, tick mark here. AD is 10, BC is 6, F is 6, this equals 6, and this is a perpendicular height. What's the perimeter? Oh, nice. So start here, 10, 15, 15 plus 6 is 21, 21 plus 5 is 26. All right, I didn't give a final answer. Well, anyway, 10 plus 6, okay, 10, 6, 5, and 5. Well, interesting. And because you're adding up all the units, it's going to be units to the 1 power. You're not multiplying units like an area. You're adding units. So when units add, they don't go up in power. When units multiply, they do. And that's why you have units to the power 1 on a perimeter and units to the power 2 on an area. All right, same thing here. This looks like 5, 5, AB equals CD, 5 and 5, AD and BC, 10 and 10. What's the area? Well, area of a, excuse me, get out of the way. Area of a trapezoid is, a parallelogram, sorry, which is like a pushed over rectangle, right? Oh, the F, this equals 6. Area equals base times height, and it's perpendicular height, so we're not going to use 5, we're going to use 6 here. So area equals base of 10 units times perpendicular height of 6 units, and area equals 6 times 10 is 60 units squared. Nine times 6. So I think this should be 10 right here, and I think this should be 60 because it says clearly 10 right here, right? So I'm going to make it this one, and it's going to be 60 units when you guys see it, right? I'll fix it by the time you get there. All right, let's see the dimensions again. Looks like we got 5, 5, 10, 6, and 6 here. Area. Area equals 1/2 base 1 plus base 2 times perpendicular height. Look back at your notes if you need that, and or the prior pages of this problem set. Base 1 is 10 and 6. 10 plus 6. There is a units here on this. And a perpendicular height of 6, and that's units. 10 plus 6 is 16, divided by 2 is 8. 6 times 8 is 48. Units times units is units squared. So 48 units squared. Do I have this one? Yep. Got it right here. Looks like 10 plus 6 divided by 2 times 6. Good. 48 units squared. Let's see what else. What word do we use to measure the height of an airplane flying in the sky? More than one answer may apply. Altitude is the real answer, but perpendicular height is a synonym of altitude. So either of those. This is no and no. All right? 90 degrees, 90 degrees. That's what an altitude is, and that's what a perpendicular height is. If you measured this at an angle, it wouldn't tell you the height. It would tell you your distance from the thing. So say you're over here, right? Oh, you can't see. Say you're standing here, and you're looking up at this airplane far away, and you measured this distance, right? This is not the height of the airplane. This is how far it is away from you. You would want to know how high it is to the ground here. That's what the perpendicular height is. All right, so make sure you're following in the title of this lesson. It's Geometry Semester 1. It's the 3rd unit called Area and Perimeter. It's the 5th lesson called Area and Perimeter of Trapezoids and Parallelograms Practice. It's on creatormath.com under the Geometry tab. And I hope this helps.